All right, well, half of what we want to do with trig is finding unknown sides, like we just demonstrated. But many times we know the sides of the triangle and we don't know the angles. And that's the other thing that trig can do for us. It can find unknown angles if we know the sides. So for example, we said we have a 3, 4, 5 right triangle. Probably off the top of your head, you don't know what these two angles are. Is there any way you can do that without using trig? If I told you to find the measures of those angles in a 3, 4, 5 triangle and you weren't permitted to use trig, how could you do it? Well, but the only other way besides trigonometry to do it would be to make a scale drawing of this thing. You know, get out a ruler and maybe make the length of A 3 centimeters, the length of B 4 centimeters, and make sure that this is a right angle down in here, measure everything off, and then get out a protractor and measure the size of A and the size of B. And there would be some error involved in that because you'd probably make some drawing mistakes. But using trig, it's actually fairly simple to find that angle. Because capital A, the 3, relative to the angle little a, that's the side opposite A. And capital B, which is equal to 4 units, is the side right next to angle A, so that's the adjacent. And then you ask yourself, okay, what trig function relates opposite to adjacent? SOHCAHTOA, that would be the tangent function. So with opposite and adjacent, we're going to use the tangent formula. Even though we don't know what angle A is, we can say that we know that the tangent of A is equal to the opposite over the adjacent, which is the same thing as 3 over 4. The tangent of A is the opposite over adjacent. Opposite's A, the opposite's 3 rather, the adjacent's 4. So the tangent of A is 3/4 or 0.75. All right, so that says that whatever angle A is, its tangent is equal to 3/4, but that doesn't tell me what the angle A is itself. So how do we get A out of all that? Well, to solve for A, we have to somehow undo what the tangent function does. And a function that undoes another function is called an inverse function. An inverse function always undoes a function. So, for example, a non-trig example, how would we undo squaring a number? If you take a number like 2 and you square it, and then you want to undo what you've done, you would then take the square root of it. The square root function is the inverse function of squaring. Likewise, the inverse tangent is the inverse function of the tangent. Just as the square root of the square of 2 gives you 2 back. Now, if you take 2, you square it, and then you take the square root of it, you're right back to where you started at. Likewise, the inverse tangent undoes what the tangent function does and gives you what you started with. Here's the notation that we use for it. For inverse tangent, we write that as tangent with a little -1 superscript, or sometimes older notation you'll see is the arc tangent. Likewise, for inverse sine and inverse cosine, we either use the -1 superscript or we use the arc sine, arc cosine notation. If you look on your calculator display, your calculator keypad rather, you pull up the calculator cam. If you look on your keypad, right above the sine button, you'll see that notation sin with the -1 above it, and likewise for the cosine and tangent. So the inverse trig functions you access by first hitting the second key and then pressing those buttons. Now here's an important note. Make sure you understand this. That tangent with a little -1 superscript, that does not mean 1 divided by tangent. Now I understand that x to the -1st power is the same as 1 over x. In algebra, that's what it means. But the trig notation, that's not at all what it means. The tangent with a little -1 superscript simply means inverse tangent. And all it means is we're trying to find the angle whose tangent is whatever the ratio happens to be. So taking the inverse tangent of the tangent of an angle, undoes the tangent and gives you the angle. It gives you what you started with. Likewise, taking the inverse of the sine undoes the sine function, gives you what you started with. Inverse cosine undoes the cosine function. All right, well, how does that help us to solve our problem? Well, here's where we were. We said we knew that the tangent of A was 3/4. We want to find A. So to undo the tangent function, we take the inverse tangent. But remember, first rule you've ever learned in algebra was probably whatever you do to one side of the equation, you must do to the other side. So if I take the inverse tangent of the left side of the equation, I've got to take the inverse tangent of the right side of the equation too. So the inverse tangent of the tangent of A is equal to the inverse tangent of 0.75. Well, we already said when you take the inverse tangent of the tangent, you're left with what you started with, A. So that says that A is equal to the inverse tangent of 0.75. In other words, A is the angle whose tangent is equal to 0.75. Taking an inverse trig function always gives you an angle. All right, well, how do we figure out what the inverse tangent of 0.75 is? Well, that's something we do in our calculator. So we go to the calculator. Instead of pressing the tangent button, we press second and then tangent. And when we do that, oops, helps to have it turned on first. Second and then tangent. Notice we get that inverse tangent notation showing up. You put in 0.75 in the parentheses and press enter. And that tells us the angle whose tangent is 3/4. It says it's roughly 36.9 degrees. Therefore, the inverse tangent of 0.75 is angle A, which is equal to 36.9 degrees. Right? So in a 3-4-5 triangle, one of the angles is always 36.9 degrees. Probably not something you knew off the top of your head. Well, somebody might say, well, do we have to use inverse tangent? Could we use sine instead to find angle A? The answer is sure. Look at this triangle. This is not a 3-4-5 triangle. This is different. But this time we're given side A is 5 and the hypotenuse is 10. And let's say we want to find angle A. This time I wouldn't use the tangent function because I don't know the side adjacent to A. Now I could use the Pythagorean theorem to find it, but it'd be easier to use what I already know. And what I already know is the side opposite A and the hypotenuse. And the trig function that relates opposite to hypotenuse is the sine function. So I can start out by saying I know the sine of A is equal to 5/10. Opposite over hypotenuse. Sine of A is 5/10. That's the same as a half. Therefore, A is the inverse tangent, the inverse sine of 0.5. To undo the sine function, we take the inverse sine. Inverse sine of the sine of A is just A. And the inverse sine of 0.5 is 30 degrees. Again, on my calculator, if I do second sine of 0.5, it returns 30 degrees. So I know that's a 30-degree angle. All right, give this a try. New triangle, and here's what you should have done. You should have realized that the 4-meter side was the side adjacent to angle B. The 10 meters was the hypotenuse. And adjacent and hypotenuse, it's the cosine function that relates those two, exokatoa. So you know the cosine of B, whatever B happens to be, is equal to 0.4. Therefore, to find B, take the inverse cosine of both sides of the equation. And the inverse cosine of the cosine is just the angle itself, that's B. So B is equal to whatever the inverse cosine of 0.4 is. And that's something that we do in our calculator. So now I go to the calculator and I punch in inverse cosine of 0.4. And it tells me that that's about 66.4 degrees. So choice number 1 was the correct answer. That angle was a 66-degree angle. One final example. Let's say Emily goes to Italy, visits the Leaning Tower of Pisa, and she drops her iPod off of the tower when she's there. Probably not the best thing for your iPod. But let's say we're told that this thing falls to the ground 2 meters away from the base of the tower. That's where it lands, 2 meters horizontally from the base. And we're told that the angle that the tower makes to the ground, to the horizontal, is 88 degrees. The question is, how far did the iPod fall? What you're going to want to do here is draw a right triangle, show the 88 degree angle, show the 2 meter distance, think about the other distance that you're trying to find, write the trig ratio, and solve it. Take a minute to do that. Pause the video if you need to. Should have come up with 57 meters. All right, choice number 2 there, 57 meters. And let's look at the work. Here's your right triangle. All right, here's the base of the tower. This thing lands, rather, here's the base of the tower. This thing lands 2 meters away from it. The iPod falls through this distance that we're calling B. We're trying to find B. We know 2 meters, we know the 88 degree angle. B is the side opposite 88 degrees, 2 meters the side adjacent. It's the tangent function that relates opposite to adjacent. We're solving for the opposite side, and that's just equal to 2 meters times the tangent of 88 degrees, and that gives you 57 meters. So again, a very practical thing that you can do with this. Well, to give you some more practice with this, there are a couple things that you can do. There's a worksheet of trigonometry review problems. Some of the problems will have 2 angles that you know and none of the sides known. Some of the problems will have just 1 angle that you know and 2 of the sides that are known. But the point is, you should be able to find for each of those triangles any missing sides and any missing angles using what you know from trig. Missing sides, you can either use Pythagorean theorem to find them, or you can use trig to find them. Missing angles, you might just be able to subtract from 90 degrees to get the missing angle, or you might have to use trig. So give that a shot. There's also a WebAssign dealing with trigonometry that you can work out. And I really think that after you work on this a little bit, you'll find out that this is fairly simple. You'll have, like I said, probably less problem with this than you will with the algebra that you're doing for the course. This is what the worksheet looks like that you're going to be doing. And the first 7 problems that you're going to be looking at all have 2 unknown angles and 1 unknown side. And then the final 4 problems, 8, 9, 10, 11, have one unknown angle and 2 unknown sides. So there will always be a total of 1, 2, 3 things that you don't know from the beginning. There's either going to be 1 unknown side and 2 unknown angles to find, or there's going to be 1 unknown angle and 2 unknown sides to find. So for each one of these, there are going to be 3 things that you're trying to find.